Hi, welcome to the CP Chemistry Unit 1.2 video notes. Before we begin, I just want to remind you that these videos will have two parts. The first part is a presentation overview, and the second part is where you will record your notes. So you do not have to take notes for the first part. I will let you know when you need to start recording notes. All right, Unit 1 is on scientific skills. And so far what we've talked about in this unit are measurements. And we looked at mass and looked at the equipment that we use to measure mass along with the units for mass. We also looked at volume and the equipment that we use to measure volume, and we also looked at some units for volume. In this video, we are going to focus on density. Now, density is probably a term or a word that you've heard before, but maybe you're not quite sure what it means. So before we go into what it means, I want to sort of test your understanding with this riddle. Which is heavier, a pound of feathers or a pound of lead? Pause the video now and think about the answer to the riddle, and when you press play, the answer will be revealed. All right, the answer to that is neither. When the question asks how heavy, which is heavier, heavy refers to the mass, or on Earth, the weight and the mass are the same things. So it's really referring to the mass here. And since they have the same mass, a pound of feathers and a pound of lead, that part would be the same. So they weigh the same. However, if you did mention lead as the answer, you were probably thinking of density, not mass. Okay, so what is density? Density measures the compactness of a substance, and dense substances are compact, meaning that their particles are close together or more tightly packed. We have at the bottom here an image of two different substances, one in box A and one in box B. Based on the definition of density, which substance is more dense, the one in box A or B? Pause the video now. When you press play, the answer will be revealed. All right, so the substance in box B is denser, and that's because the particles are more closely packed together. You don't see a lot of spaces in between, whereas in the particles in box A, there's a lot of space in between them. Okay, so now that we talked about what density is, how do we calculate it? Density is calculated through this very simple equation. D equals m over v, which is density is equal to mass divided by the volume. We're going to look at an example where we can apply this calculation. So in this example, it says calculate the density of 3.0 milliliters of a liquid that weighs 12 grams. One of the first things we should do is rewrite the density equation, because that sort of helps us ground ourselves in terms of what information we need. Now we can analyze the problem and find the information that's given to us. So the 3.0 milliliters is our volume. How did I know that? Milliliters is a unit for volume, and this is where units are super helpful. So when you see milliliters, you know that's volume. Over here, the 12.0 grams, that would be our mass. I have two clues for that. One, the units, grams is a unit for mass, and the other is weighs. So that's my clue that the 12.0 grams is our mass. Once we know our mass and volume, we can go ahead and plug that into the density equation. So I write density is equal to 12.0 grams divided by 3.0 milliliters. I do my math, and I get the density to be 4.0 grams per milliliter. That will be the answer. You'll notice that the units for density is simply the units of the mass unit divided by the volume unit. So whatever your mass and volume in, that will be the unit for your density. If my mass here was in kilograms and my volume was in fluid ounces, my density unit will be kilograms per fluid ounce. All right, now that you've seen an example of it, it's your turn to do this with this CFU. CFU says a metal bar weighs 40 grams and has a volume of 5.0 milliliters. Calculate the density of the metal bar. You're going to do your work and on a separate sheet of paper, and then when you are ready, press play and the answer will be revealed. All right, so let's take a look at the answer here. 40 grams is our mass, 5.0 milliliters is our volume. We can plug that into our lovely density equation, and when we do, we get the density to be 8.0 grams per milliliter. Again, notice that my units for density match the units for the mass and volume. All right, we looked at how we calculated density. Now let's talk about density in terms as a property. So density is a physical property of a substance. And what do I mean when I say physical property? Density is a physical property is a characteristic of a substance that you can observe without changing or destroying the substance. Another example of that will be color. So if you look at the color of something, you can look at the color without changing it or destroying the substance you're looking at the color of. Shape as another one, like you can see the shape or feel the shape of something and it wouldn't change that thing. Mass and volume are also examples of physical properties. All right, so why is it helpful that density is a physical property? That's because densities of the same substances are the same. What do I mean by that? And you can utilize density to identify a substance based on that. So what do I mean? If, for example, you had a liquid that had an unknown liquid and you determined that the density of that unknown liquid was 1 gram per centimeter cube, you could look up a density table like you see here and figure out what that liquid could possibly be. So in that case, if the density of the unknown liquid was 1 gram per centimeter cube, it would most likely be water. So the main thing is if the densities are the same, the substances could be the same. It's a possibility it's the same substance if the densities match. Let's look at an example of that. So in this example, it says a metal bar has a density of 10.2 grams per centimeter cube. This metal is most likely. So we're going to look on our density chart, and I'm looking for something with a density close to 10.2 grams per centimeter cube. Remember that last digit there can be a little bit off, so that sometimes can happen from experimental error. All right, so I'm looking at my chart here, and the only metal that's closest to it, according to this chart, would be silver. And so I would say the answer is silver because the density of the metal is closest to silver. All right, it's your turn to try it now with the CFU. So a shiny metal solid has a mass of 29 grams and a volume of 2.5 centimeter cube. This metal is most likely. So for this one, it's a little bit trickier than the example I did because you don't have the density, so you're going to have to calculate that first. Once you get the density, you're going to try and match it to one of the metals in this table. All right, do your work on a separate sheet of paper, and when you press play, the answer will be revealed. Okay, so here is the answer here. The first thing we did was we would calculate the density by taking the mass, which is 29 grams, dividing it by the volume, 2.5 centimeter cube. Remember, I know this is the mass because it says, and also the units. And I know this is the volume because it says, and also, again, the units. All right, so I go ahead and plug that into my density equation, and I get the density to be 11.6 grams per centimeter cube. And then I look on this chart here, and the metal or solid that matches with it would be lead, which has a density of 11.34. It's the only one that's close to it. And so I would say the solid is lead because the density is the closest to lead. Okay. One last thing I want to talk about when it comes to density is related to whether or not something sinks or floats. So if you notice that ice on water, it will float. And that's because ice is less dense than water. So denser things tend to sink. They will fall to the bottom of something that's less dense. And less dense things will float on top of something that's more dense. All right, so you're going to test your understanding with that with this CFU, number 3, true or false. We have a column of many different liquids here. So true or false, the dishwashing liquid is less dense than the lamp oil. Explain your answer. So here's the dishwashing liquid in blue, and here's the lamp oil here. Take a moment to think about your answer to this. You can work it out on a separate piece of paper if it helps. When you press play, the answer will be revealed. Okay, so the answer is false. The dishwashing liquid sinks, so it's below the lamp oil, so it's sinking below it. So the dishwashing liquid would actually be more dense than the lamp oil. All right, so just some key ideas what we covered so far. We talked about density as a measure of compactness, and we also looked at the equation for density, mass divided by volume. We mentioned that the units of density is the mass unit divided by the volume unit, and we read that as, like, in this case, it would be grams per milliliter. Density is a physical property, so and substances made of the same material will have the same density. We also looked at the relationship between density and whether or not things float or not. So less dense things tend to float and more dense things tend to sink. All right, so now it's time for some notes. We did our overview. You don't have to skip the first 2 pages of your notebook because you did that already, but you just go straight to the next page of your notes at this point. Okay, so here's the first notes you're going to take down. What is density? Go ahead and copy these notes down while I read them out loud. We talked about this already. The qualitative description of density is that density measures the compactness of a substance, and we have two different substances, A and B. Density is not mass. It does not tell you how heavy an object is on its own. And density is a measure of how much mass you can fit in a certain space. So more compact things, you can fit more mass in. If you need more time to copy the notes down, pause the video, and then we're going to go on to the next note. Okay, so what is density continued if you need more space? Okay, so density is in terms of quantitative description, density is equal to mass divided by volume, or D equals M over V. Mass measures the amount of substance, and the units here are grams, kilograms, pounds. Those are examples of units. And volume measures how much space an object takes up, and the units here could be liters, milliliters, ounces, centimeters cubed, etc. Remember that the units for density will be whatever the units of the mass units divided by the volume units. All right, if you need more time to copy this information, pause the video, and when you're ready, press play. All right, finally, we have an example here of how we calculate density. So you have a mass, then you have your volume here. And you just plug those into the equation. You take the mass and you divide it by the volume. And the density in this case would be 6.135 grams per centimeter cube. I wrote on the side that the density could also be written as 6.135 grams per milliliter. That's because centimeter cube and milliliters are actually the same units. They are equivalent units. All right, final little note that you're going to add to your notes is density sink or float. Less dense things float and more dense things sink. And so you want to draw this example. The ball floats because the liquid is denser. So the liquid is denser than the ball, meaning the ball is less dense. So the ball will float, and then the ball this should say the ball sinks actually because the ball is denser. So make sure you write this as sinks. All right, I hope you found this video helpful. Have a quality day.